Welcome to this Progressive Web App webinar. My name is Antoine, I'm a technical specialist at Google, and today I will show you why progressive web apps and how to deploy a progressive web app. So, why progressive web app? When we talk about mobile, we have two main categories, the mobile web on one side and the native application on the other side. It's not really a choice after all, because you need to have a mobile website. The real decision is deciding whether or not to develop a native application, and if so, on which platform. Some sites have chosen, like Sephora. Sephora, it's a mobile site and two native apps. But when you think about it, it's repeating the same thing 3 times. It's complicated and extremely expensive. Indeed, when you think about it, it's 3 teams, 3 projects, 3 technologies, 3 times more meetings, 3 times more code to maintain, to do at the end the same thing. The native apps, they really have a lot of advantages. So first thing, they are mobile first. So like the design is mobile and work very well on mobile. They design everything from a mobile point of view. They are fast because of the local assets. They are more visible because they are present on the home screen, and they are more engaging thanks to the push notifications. So the idea of progressive web apps is to make a fusion between the native mobile apps and the mobile web, and to add to a given website the speed, the offline capacity, the add, the add to home screen feature, like to make the app more visible and to make the web app website more engaging, as well the push notifications. So let's see a quick demo on what the progressive web app looks like. So first you go on the website, and if you have service worker registered and valid manifest.json, we will see together like what service worker and manifest.json. But if you have some requirement, you have this small banner which said add to the home screen. If you click on this banner, then you have another pop-in which says add to the home screen. If you click on add, you have a feedback from the navigator which say like, okay, this has been added. And then you have the icons on your home screen. The interesting thing here is this is not a Chrome shortcut, right? This is like a native icons from a native apps. When you click on the icon, you have a splash screen, and as you can see now, the app is launched in full screen mode. So you can choose to keep the URL bar if you want, but here on this website they decided to remove it. So let's see together how to create this feature with the add to home screen. So you will need around like 1 hour to implement that. So it's 3 simple steps. First step is to create a manifest.json file. Second step, to create icons. And third step, register a service worker. So you have to create a manifest.json. So it's a JSON file with some content. For example, as you can see here on the left, we have the name, we have a short name, we have an array containing icons, start URL, display standalone, which means that we remove the URL bar. Background color is to have the part of the, like the background with the URL. You can pick the color you want, and the theme color as well. It's for the splash screen and everything. So you can decide to write your own manifest.json manually, or you can use this web app manifest generator, which is a small app, really handy one. So you can upload an icon, and then you fill that form, and bam, it generates everything for you. It's something that I always use. You can also add like the icons for iOS, though they are not the same. Here, just add the Apple Touch icon. So if you use a fav icon generator, like there is like plenty of them on Google if you search for them, and they will be they are able to generate this code for you. Okay, so to earn the right to be on the home screen, it's mandatory to have a minimal offline support. So we will see now how to add the basic offline support to your application and to your website. So here, disclaimer, having the whole site offline is not always necessary. Think about it. Do native apps always work 100% offline? If we take an app like Uber, like if you are on the plane and if you launch the Uber app, you will maybe be able to see your previous trips, but you will not be able to order a cab, obviously. So it doesn't matter if your app doesn't work fully offline. The important thing is to not show the Chrome dinosaur when when there is an error. So a simple example of basic offline support. Trivago, when you go on the website and when you are offline, they are throwing an offline page with a really simple game. Okay, and there you have a CTA just asking you to reconnect if you want. So to add this basic offline page, you will need around like 2 hours, obviously depending on the complexity of the page and the design and everything. But first step, you have to create a service worker, and we'll see what's a service worker. Second step, you have to create the actual HTML, CSS offline page. And third thing, you have to register this service worker. So I talked a couple of times about service worker. So what are service worker? A service worker is a proxy which can intercept and route requests. The service worker can also listen events. So it's a piece of code that sits between the application and the web. It's basically a reverse proxy, if you are familiar with this concept. But if not, every request that our application will make will go through the service worker. And then in my service worker, I can decide to route these requests to either like save that request in the cache or maybe go on the internet, go on the network to fetch that request. So the service worker has some special rules. It's important to have your service worker at the root level of your project because the service worker can only handle requests for client under its scope. What does it mean? So quick example. Let's say you have let's say we are a SaaS company, so a software as a service company. We are awesomesas.com. On awesomesas.com, there is two teams: the marketing teams and the actual developers working on the app. So awesomesas.com has awesomesas.com/app, where the web app lives, and the /blog, where like the marketing team handle like the content is promoting the app and everything. And let's imagine that the /blog, it's a WordPress website. What we don't want is the marketing teams be able to install some WordPress plugin that will mess with our /app, right? So if you install a service worker on a given in a given folder, in a given directory, the service worker will only able to manage requests from that directory. I hope it makes sense. So you have to create the service worker at the root of your project. Another important thing with the service worker is to be sure that your service worker is not cached. So I mentioned that the service worker will have some rules to route request and do like really cool stuff that we will see together. But important thing is you don't want your service worker be cached on the client on the client side. So here, for example, with Apache, I put no cache, max H0 on that. if I do any mistake on my service worker, what I don't want is my user using a wrong service worker for maybe couple of hours. So by default, Chrome will always revalidate the service worker within 24 hours, no matter like what are the cache directive that you put on this file. Okay, so max is 24 hours, but a good practice is to put a max H0, no cache, no store, this kind of cache control headers. I mentioned that you should have your service worker at the root of your project. If it's not possible, you can always write an Apache rule that I don't know if maybe you use Nginx or something else, but here on one website that I have, my service worker, like the actual file, is on my front end, like in my front end code, but I serve it in the root thanks to this Apache rule. So when I hit my awesome website.com/service worker, we return the file that is actually at my cold website /path/asset/service worker, blah, blah, blah. Okay, so now the service worker, in our service worker, we can listen for events, and we do that with the add event listener fetch. So we listen all the fetch events. So, and we have to register our service worker as well. So you can do that in app.js or like your where you write your JavaScript normally. And what we will do here is to register a service worker that is sw.js, and we will register this service worker proxy for our application. And in our example, just before, I put console log on all the events that we make, and we can see that if we run this service worker, we will see all the requests that we make in our application. So I guess you start to understand that with a service worker, we will be able to catch those requests and to create some specific logic to handle them. So yes, we can intercept and modify requests in our service worker. So the basic offline page that we want to create basically will handle this situation. So when we have when we are connected to the internet, so the request will go through the service worker and then to the network. If we lose our connection, what we will do is the request will go through the service worker, try to go to the network, and it will fail because we are not connected to the internet. Then we can respond with something else from our service worker. Then this something else will be our offline page. Let's see the most basic offline page you can create. So in our service worker, once it's registered, what we can do is to listen the fetch event, and we use this event response with. So event response with ships with the service worker, and inside this function we execute our fetch. So fetch event.request. So from the event object. So we try to fetch that on the network. And we added a catch, so because it's a promise. And if this event.request fails, what we do is we catch that inside our catch, and we create a new response. And our new response is just an HTML file or like HTML content, which says you are offline. And then here I put the right headers. So this is the most basic offline page. And if we test that, so I go offline, I reload, and bam, I throw my basic offline page. So super, super simple. It's not bad, but I think we can do better. A super easy way to create an offline page is to code your offline page and to put that directly in your service worker. We will see like a more advanced way to do that, but if you have only 5 minutes, you can always like do something like this. So we have our offline HTML variable, and I use some ES6 backticks to put all my HTML and to not have to deal with the quotes. So here I created like a basic offline page, but with a bit of CSS. And instead of like putting my HTML directly in new response, as I just did in the slide before, I send back the variable. So we have something like this. And if we try that, we can see this page. So here I have this little robot, and it's actually an SVG, so it's definitely something that you can inline. So one of the most basic offline page ever. You can try that. I put everything on this glitch.me project. So PWA 101.glitch.me. So if you are looking for example of offline pages, you can visit this link slash pwa-offline-examples. But the two interesting examples are the two examples on the right. So here we have an offline page, but we will check what we have in the cache, and we say to the user, sorry, this page is not available offline, but those pages are available. So we will learn how to create this kind of more advanced page in this talk. Okay, so now let's see some advanced concept. So beyond a basic offline page with the cache API. So there is different ways to store data on the client side. So there is local storage, there is the IndexedDB, the Web SQL, the Cache API, and the App Cache. We will talk about the Cache API. The Cache API, it's a new API to store data on the client side. So it's something that you have here, cache storage on the application tab of your DevTool. And what's the Cache API? The Cache API is a system for storing and retrieving network requests and corresponding responses. So the Cache API is designed to store HTTP requests, which like goes well with this idea of the service worker of intercepting requests. So I guess you start to understand that with our service worker, we will intercept requests, and with the Cache API, we will store those requests, right? And this is will be part of our logic. We can create a cache. So with this simple code, so caches.open, and here at an argument you can put the name of a cache, for example my PWA demo, and this is a promise, and this would create the cache my PWA demo. You can try that in your browser, and this will work. You don't have to execute this absolutely in your service worker. This caches object, it's also something that you can access from the window. So we can execute this code either inside our service worker or in the console. And if we do so, we can see the cache we created. If we go on the Chrome Developer Tool and go on the Application tab, there you can see our caches. Let's try to mix the Cache API and our service worker. Our goal is to create a more advanced PWA with more advanced offline. So we have to save our assets, HTML, JavaScript, CSS, inside our cache. Let's do this inside our service worker, only when the service worker is installed. So we put everything inside an add event listener. And because most of the API in the service worker is promise based, we can use await. We can see that our assets are now saved inside our cache. But how to respond to network requests from what we have inside our cache? Let's see what we have to do to respond from the cache. First, we have to listen for requests in our service worker. Then, open the cache. If the request is in our open cache, then we will respond from the cache. If the request is not in the cache, we fetch the request on the network, and then we respond with the fetch request. So inside our service worker, we are listening for fetch event, and we are intercepting the request with the respond with method. Inside our respond with method, we will create a function called cache or network that will handle our logic that we saw on the previous slide. This function will take two parameters: the event that we'll get from our event listener, and second parameter is our cache. So let's respond to request from the cache API. So our function should check if the request is in the cache, and if so, respond from the cache. If not possible, we should go on the network. Let's see the code. So cache or network, first we open the cache, so second line. Then we check if the request is in our cache. So we use the match method for that. If it's in the cache, we store the response in response from cache. If response from cache, then we just return that request. Okay, so cache.match will return the request itself. So we have our cache or network. So if the request is not in the cache, so if all our tests failed there, then what we will do is to first clone the request with the service worker. And when we deal with requests, we can only use the request once. So we have to clone the request. And to do that, we use the request.clone method attached to our event. Then we fetch the request on the network, and here we just use the fetch. So because fetch returned a promise, we can await it, and then we just return it from the network. Let's see if it works. So I go offline, I reload, and everything works. So we succeed. So we created this strategy. So when we talk about service worker and cache and everything, we have some caching strategies and different caching strategy for different situation. And this is what we created. We created a cache first strategy, which means the request will go through our service worker. We'll try to go to the cache. Second, if this fails, we try to go on network and respond to that from the network. But what if you want to refresh the cache, or always respond from network, or set expires in the cache, or update your cache in the background, or this kind of thing? To do so, there is a very nifty library called Workbox. So Workbox is a truly awesome library, and I don't recommend you to write service worker without it. If you try to write a service worker without a Workbox, there is like 100% chance that at some point you will fail and you can do like some ugly thing on your website. So Google engineers, they released Workbox. It's an open source project, so you can contribute, but they did the heavy lifting for you. So use Workbox and nothing else if you have to deal with service worker, if you try to implement service worker. So you can have a look to the advanced example that we just created. And So go on myadvancedpwa.glitch.me. Okay, so I just said that Workbox is awesome. But let's see what we can do with Workbox through an example. I created a fairly basic app. My goal here is to show you how to use different strategies with Workbox to speed up your app and to make it available offline. So let's transform this basic app into a real progressive web app. Uh, so this app, first, quick description, is an app that fetches the prices of cryptos, so Bitcoin, Dash, and Ethereum, and shows to the user the latest price for those cryptos. Um, we fetch this basic API, and we have like a bit of CSS and JavaScript to handle that. So here we go. Let's transform this page to a pure progressive web app. So first thing, let's install Workbox CLI. So Workbox CLI is the CLI to handle Workbox. So let's install that locally. You can always install that globally, but I always prefer to install module locally. So we will want to create a pre-cache, which means that we will put our static assets into a specific cache, and we can do that automatically with Workbox. So once our service worker is set up, and when we have the install event, we go in on the network to fetch our assets, so CSS, JavaScript, and things like that, and we will put that in the cache. Once it's done, the activate event will be fired. So we can generate our pre-cache automatically with Workbox. So with Workbox, you can create with Workbox CLI, you can create a file called workbox-config.js at the root of our project. When I say root, you can you have to put that where you have your front-end assets and everything, where your front-end project lives. And so we are exporting this object. So we have a couple of options there. The glob directory, we will search inside this path. The glob patterns, like the file that we want to pre-cache. So here index.html and all the CSS that are inside CSS, our CSS folder. All our images that are inside our EIMG folder, so either a PNG or SVG. And we put the destination of our service worker, so at the root of our project /sw.js. Clients claim and skip waiting true. It is just plumbing just to avoid inconsistency in our project. So you can run the CLI with npx workbox generate SW. So this will create our service worker, and this creates something like this. So we have our pre-cache manifest, and as you can see, we have objects, an array of objects, and in each object we have the URL and then the revision, and the revision is actually the hash of our file, which means that if we update one file, let's say for example if we update index.html, Workbox will be smart enough to regenerate the hash and then to only ask the user to reload this file. As usual, we have to register our service worker, so in our app.js or even inside our HTML if you want. So let's try that. So when we test our app, we can see that it's not working very well. we are sending a 200, so we are showing something to the user when offline, but not very useful. And the external assets are not available offline. So how to cache them? And the external assets are for example, my CSS library. I use like Materialize here, that is hosted on the Cloudflare CDN. And the fonts as well, the material icons fonts, everything is hosted externally. So how to cache external requests? So what we want is to cache everything coming from cdn.js.cloudflare.com and everything coming from fonts.googleapi.com. And to do that, we will use a specific strategy called stale while revalidate, which means that we will always serve these assets to our user from the cache first. And then in the background, we will make a request on the network to check if our assets changed, if we have a new version of them. And if it's the case, what we'll do is we will update the cache. So with the stale while revalidate, the first access will always serve the stale assets, and then in the background we will update them. And to do that with Workbox is super easy. So in the service worker that we generated, what we can do is to create a route, and then we set a specific um, a, a specific strategy to handle that. So here, everything that will be cloudflare.com will be handled by the stale while revalidate strategy, and we only want to deal with GET request. So if we do that, we can see that the new cache has been created, workbox-runtime. And in that cache, we can see that we have our resources from Cloudflare, the materialize.css, and our JavaScript. Let's try that offline. So it's better, but still not ideal because our AJAX requests are failing. So now, how to cache our AJAX request? So what I want to do is to cache the request from api.nomics.com. I want to cache the responses. So, but we have to think a bit about our application and what could be the best strategy for this this request. So I want to serve to my user the latest Bitcoin price and everything. So I always want to go on the network if the user has internet. If the user loses his connection, then the thing that we want is to fall back on a response that we stored in the cache. So each time we go on the network, each time we make a request to this API, what we will do, we will store a copy of that request in our cache. And we will use this copy only if the user loses his connection. So this is how we do it in our service worker with Workbox. So first thing, we have to use like workbox.routing.register root as we already did. First parameter will be a regex of the request failing in that strategy. So all the requests coming from api.nomics.com. And then the strategy that we will use is the network first strategy. Then Workbox already created this strategy. And then we only want GET requests. And now if we test, it works. So everything is here. I have my CSS and main app.js, the JavaScript that I wrote myself in my precache. My libraries are cached with a stale while revalidate. So always serve from the cache, and then we check on the background if there is a new version of that library, because it's unlikely that the library will change. And third thing, for all the AJAX requests, we always fetch them from the network, and we store a copy of those requests in the cache, and we serve those requests from the cache only if we are offline, and everything is working. So super simple. You can check this project. I put it on GitHub, so /PWA dash workbox. Okay, so if you want to add workbox to your build process, one easy thing, there is as well plugin for Webpack and all other um, bundler, that kind of things. But if you want to use the workbox-config, so the important thing here is, like, in your workbox-config, you put a service worker author-c, and here, for example, you can name it service worker-dev, and the service worker that will be used in production slash service worker as destination. And in our service worker.dev, we have all our um, uh, custom strategies and everything. But what we want is to update our precache. If we make like modification to our own app.js or our CSS and everything, and if we try to rerun workbox CLI, all our custom routes will be erased. And to avoid that, create another service worker only for development, and put workbox.precaching.precache and root with an empty array, and workbox CLI at build time will inject the precache, so our files, the the file that we want to precache with the hash and everything inside this array. And then when we generate our service worker, this is what we get. We get our manifest, so the array is populated with the URL and with the revision based on the hash of that file. Thank you so much for watching this webinar. And as a conclusion, my point here is PWA, the basic building block of PWA are really, really simple to set up on any website. There is more than just the at-home screen and some basic offline capacity, but I didn't have time to cover everything. So I encourage you to have a look online and check the different API. We have, for example, the background thing to replay a request even when your app is closed. We also have the push notifications and many other things. I didn't cover, for example, the push notifications, but I recorded a video about this, and I recorded like other video about like how to implement PWA in general, something that we already discussed in this presentation. But I split everything in 9 videos, and I put everything on that website, the uxworkshops.com. So you can access to the video and the resources with the password speedRace and with the R capital. So thank you so much for joining this webinar. And if you have any question, feel free to send me a tweet at Antoine BR, or you can send me an email at ne-speedrest@google.com. Thank you so much, and I wish you a really good day. Bye bye.